Okay, so for this one, like I said before, put your equation in your calculator because we don't give you a 0 or an x-intercept. And when you plug it in your calculator, an image like this will pop up. Then what I would do is I would hit trace. And I'd say to myself, okay, it looks like it crosses at -1. So I'd hit -1, enter. And if at the bottom of my screen it says x equal -1, y equals 0, as long as it says y is 0, that means you found an x-intercept. Therefore, that brings us over here, and we put that number on the outside of the synthetic division box, and we start doing synthetic division to break down to find the remaining values, x values, by factoring. So then when you do synthetic division, right, you add inside, multiply out. You guys should, I think you've got that down. You end up with this. So it drops a degree, so it becomes 1x cubed plus 1x squared minus 10x plus 8. At this point, if you think you can factor potentially by grouping, go for it, but you can't. So then you try to find another x-intercept. You can either look at your original picture or you can plug this new equation in. If we look at our original picture, we say, okay, it looks like it touches the x-axis at 2. So again, hit trace to enter, and it does indeed seem to be an x-intercept. So we do synthetic division using the 2. Now again, you're always working with the reduced equation. So that's why we put a 1 here, a 1 here, a -10 here, and an 8 here. Because you keep working with the reduced one. You do synthetic division, and you end up with 1, 3, -4. So if this guy drops a degree from x cubed, it turns into 1x squared plus 3x minus 4. Once you're down to a trinomial, you can usually factor it. So what combo multiplies to -4 that adds to 3? 4 and -1. So we made our factors. And then to find the remaining zeros, you set each factor equal to 0 and solve. And that's how you get x is -4 and x is 1, which you see over here. The degree for this one was 4. Therefore, we should have 4 x-intercepts, which we see right here. Remember, their factors are listed above. You move the number beside the x and put parentheses around it. Y-intercept is 0, 8. When you put 0 in for all the x's, what's remaining is 8. So here's our y-intercept. You can choose what you want to scale by. I chose 1 in this case. And in behavior, we reviewed on the last view, but it's written down here. Okay, so for this one, don't worry so much about the local min, local max. You can just approximate. So when you look at your picture, okay, so we're going to put this equation in our calculator. When you put x to the 4th minus 3x squared minus 4 in your calculator, this image pops up. Kind of looks like a W, right? Kind of like that. So if you hit trace and you enter the number 2, you see that's a x-intercept. If you hit trace, -2, enter, you see that it's also an x-intercept. Now, where you have a low point in a region, those are called local mins. Where you have a relative high point in a region, that's a local max. So if you give these values, you can just hit the trace button, move your cursor left and right, go on top of wherever you think the lower high point is, and just say the ordered pair, for example, is 1, common -6. You can approximate or just look at it. So this would be the point, and then the actual max value is the height. So you would say the max or min value would be -6. So the max or min value is always whatever the y part of the ordered pair is.